Yeah. Hey, how you doing? Yeah, so I'm Nate. Thank you for the introduction. Thanks for coming out. Thanks for having me. Flow-based programming is what I wanted to talk to you guys about today. This is sort of a technique that we use at Conductrics to enable people to sort of, in a way, customize our product or use it in novel ways. And I think that it might be interesting for at least some of you.
If you're going to sit, you can use this one, and then you run it over the mic.
Okay. All right. Thanks. Thank you. So anyway, I think it might be interesting. There's some fun techniques in here. I think it's brutally simple. I don't want it to seem like it's going to be, you're going to learn something like groundbreaking necessarily in terms of like technique. It's just sort of like a set of tricks that I think we found, at least for us, it's been really useful. So you guys no doubt have heard of, and I'll explain what we do in a second, but you guys have no doubt heard of If This Then That, or like Zapier, or this Microsoft Flow thing, which is a similar one. You know, and all of them basically kind of are, in a way, about the same sort of core concept, which is being able to pick some kind of trigger from like a library of triggers or whatever, and then be able to pick some kind of action or like actions that are going to take place when that happens, right? And then like, there's a Microsoft Flow product, which is similar, or they call it Power Automate now. And you know, these screenshots I just stole from their pages. It's just, you know, the basic idea is that you get these, all these things provide, you know, iOS is another one where you've got these building blocks and iOS shortcuts, and you've got these building blocks that you can arrange into some kind of action that's going to be triggered by Siri or whatever, right? So you guys are all probably have run across at least one of these things. Here's another one, Zoho Flow. This one's more sophisticated, and you know, it's small on the screen, but you can see that you're able to sort of arrange a bunch of different tasks together into a diagram and sort of connect them and do all this fancy stuff. And you know, for us programmers, big deal, we have JavaScript or we have whatever other coding language, but for a lot of times, at least for us, I have non-technical users that are very intelligent, know exactly what they want, but they're not coders and they have no interest in becoming coders. And I don't want to try to make them into coders. So what this talk is going to cover is basically how can you build something like this, but for your own product. If that, you know, depending on the situation, that may or may not make any sense. But along the way, we'll call some functions in some interesting ways and so on. So all of those products, right, they provide sets of building blocks, and then the users are able to arrange those building blocks as they see fit. This can be loosely called flow-based programming. Some people might disagree. You know, there's some people have a more technical definition of flow-based programming, but I think these are all at least in the spirit of flow-based programming, and so will be the stuff that we talk about. And that's just, you know, any situation where you're able to usually visually, you know, sort of arrange a series of steps together in an ad hoc way with ad hoc timing, ad hoc branching, and so on and so forth. Sort of programming visually. So I thought it would be fun to show how we've kind of made our own version of this using JavaScript. In a way, it's just a neat way to use functions. It kind of gets your brain tingling a little bit, at least for me. It's kind of helped me think about the flexibility that JavaScript provides in a different way. I think it's a helpful pattern if you ever run across a need in the product that you're building to implement some kind of custom workflow or a macro or any kind of automation or anything like that that's got that kind of feel to it. So why did we do this at Conductrics, and real briefly, what is Conductrics? It's a system for, as Shamoon mentioned, for predictive targeting, which is a subset of machine learning. Basically, the idea is, you know, if you have a website, you might use us to initially test different pieces of content or different offers or something like that. And we will, over time, notice that one or another of these offers hopefully matters more or is more attractive to certain visitors, and we'll start streaming those off. We'll start adapting the website or the app or the back-end system or whatever it is for you, so that more people see the correct thing. But you can just use it for simpler stuff like A/B testing and multivariate testing, that kind of thing. Everybody's familiar with, at least conceptually, what A/B testing is. Okay. It's amazing how, like, my wife knows what A/B testing is now, and she's very non-technical. It's just one of those, like, algorithm has become like almost a derogatory word. I love that. Like this damn algorithm. Anyway, so our stuff is used on, and this is important, on web pages, native mobile, on servers, and in any kind of back-end thing via APIs. So the simplest A/B test type case, like the thing that people use us for first often just to get their feet wet, is a simple A/B test. So let's say that we're running a business, let's say it's flash sales, and today we're selling these smartphones, and this is our landing page. And we want to run an A/B test where instead of selling these phones, we're selling a Lana Del Rey album, just for some random reason. She's kind of the patron saint of our company. So there's three changes that we've made. So this A/B test, right, conceptually, it takes the original page and makes 3 changes to it. Changes the image, changes the headline text, and it changes the descriptive text over there on the right. And so you can think of that conceptually if you were to, like, write this, if you were to draw it on a cocktail napkin, you might draw it something like this, right? The program, quote unquote, starts. It picks A or B, just randomly. If it picks A, we're done. If it picks B, we make these changes, right? Any of you could write this JavaScript in your sleep. Like, it's really not a big deal at all. And so often when we meet a client for the first time, they'll tell us that they want to run a really, really simple test like this. But invariably, there's other stuff. Even in the simplest cases, there's other stuff. But only for certain people, only after some other things happen. A lot of times there's complicated page load timing problems that we have where the thing that we want to change isn't on the page yet and all that kind of stuff. I'm sure anybody who's worked on the front end knows what I'm talking about. And so on and so forth. And so the thing that we thought was going to be really simple quickly becomes, more complicated, where, like, we said, oh, well, we're not going to, we don't want to do this test on mobile. We're only going to do it on the desktop, and we're only going to do it based on certain campaign IDs, like the social campaign IDs. They're in the URL or something, and we're going to have to look up some information first. And by the way, that's asynchronous. And then we're going to check some kind of customer segment, and only then are we going to allow them into the test. And now we're sort of back where we started, but if we choose B, by the way, we've got to wait for some other thing to do its work first. Then we can make our 3 changes. And by the way, we also have to do some kind of integration with analytics. You get the idea. And every customer has a different one of these things, and it changes day by day. And they want to be able to do this themselves. So we got to thinking, well, can we somehow provide some kind of building blocks that can do all this kind of stuff, evaluate conditions, look up stuff, wait for stuff, make the page changes that users can arrange into some kind of flow. And so that's what we did. Here's a quick little demo of just what it looks like in the UI. So there's the user creating the A/B split. And then if the B selection is selected, then they're going to, you saw us punching in the Lana Del Rey, text and so on. Here's the image. This is all going by fast, but, the details don't matter. So now I've set up the 3 changes for the B experience. And then I can drag in another condition. I can say that I only want this thing to run in Europe, for instance. And then I can drag all the other stuff under that condition. And then maybe I want to do something with Google Analytics, and there's something about sending an event to Google Analytics and blah. And the output of this thing that we're going to store is a JSON tree. Does that make sense?
I'm sorry.
Yeah, go on.
What do you use to have that kind of the drag and drop stuff? Is that all canvas based, or is it like some cool DOM manipulation? Or?
It is on the canvas. It's via D3.
Okay.
If you know D3 JS. And I'm not really going to explain the UI all that much, but I do have a couple of links towards the end with resources if you wanted to build something like that yourself. D3 is awesome. Love to talk to you guys about D3 sometime, but there's not enough time for that right now. That's how that's built. And the important thing is that, at least for our purposes tonight, is that the output of this thing is just this JSON tree. Obviously native to JS, easy to store, compact, stick it in whatever database you need, query it, blah, blah, use Mongo, use Postgres, whatever. Super compact to send over the wire, so it's kind of ideal for this kind of thing. Compresses really well. So what does it look like? Now I've simplified it a good deal from the actual code that we use, which is not important. This is substantially the same. So conceptually, if we, there's our diagram that we started off with on the right, and then sort of I've just got arrows pointing to the different things. So as you can see, we start off at the root, which is an array of, I call them nodes, but just these objects. So the concept is that everything in this tree is one of these nodes, and that each node has a type. So there's one called pick1, there's one called log, there's one called text, there's one called image, and so on and so forth. And each one of those corresponds to a JavaScript function. So all we need to do is build an iterator that can walk through this tree and call the appropriate JavaScript function, passing these other little bits of information like selector and text and so on to the function, right? And if we do that, then we'll have our processor, and we can kind of build whatever we want. Oh, very, 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 very possible that there is. Yeah. Yeah, no. That's sharp eye, whatever you found, you probably some comma or something like that.
No, it's
Oh, yeah. I took a screenshot of the actual thing in memory. But yeah, no, you're right. That would not parse as JSON. But you get we do get the idea. Okay, good. So let me just show you real quick in the code how this actually works. So how do I always get confused. How do I get?
Old top.
Yeah, I know that, but
escape.
I guess I have to escape out of here. I never know how to do this. Okay, so let's just start with a simplified version of it. So I've got 4 versions, which I'm going to whip through really fast, hopefully. So let's just start with a really, really simple list of tasks. So there's no hierarchy yet. So as you can see, here's my array. These are legit, I think. And so I've got 3 items. 2 of them are of type text, and 1 of them is of type image. Over here, this is my code that actually runs. So this is just JSON that can be stored wherever you want. And this is, of course, legal to run. Like this framework can be used in Node, or it can be used in the browser or wherever. So here are my handler functions. So up here, I just create I create an object. There's various ways you can do this, and later on, one of the later version of this uses a class that encapsulates this stuff. But if you just want to get down and dirty, you can just create a set of a handler object in there. Create however many functions you need. So here's one called text, and that's going to execute when we encounter a node with type text. Here's one called image, and that's going to be executed if we encounter a node with type image. And then we've got this is our main function. So we just take a list of tasks, an array of tasks, we iterate over them. We grab our handler function by just, so each time we go through this, it's one of these nodes. So that means that task.type is text or image. Therefore, it's easy to grab the appropriate handler out of the object, and it's easy to execute the function using apply. Because we're using apply, inside of the function, you can refer to this, and this will be the object that you're processing. Okay, does that make sense? So really, really simple. So that means that all you have to do is load that JSON. And remember, I'm not, this is just like boilerplate code. Wherever you get the JSON from is of no importance. So you load the JSON here, it's just in a browser, and then you perform the tasks, and that's it. So here's my little demo, and I can reload the page and see that, and then like if I wanted to prove to you guys that it works, we could put some exclamation points here or something like that, and then you see them there, right? So what I like, well, so now let's look at the next version of it. So the next version of it is where we implement the hierarchy. So here's the stuff that we already had earlier. And as you can see, I've added a few additional handler functions. Like I've added a few new types to the stuff that I'm supporting in our document. Something called check URL param. This is just as an example. Something called pick one, and a couple other ones. There's one called log, just to log a message in the JS console. So let's look over here. So the idea conceptually is that when we iterate through, the first thing we're going to do is we're going to check a URL parameter, and if the CID URL parameter is equal to 1, 2, 3, then we're going to keep going. If not, we just stop. Then we get here, and we're going to pick one of our two children. And whichever one we pick, we're going to iterate into that one, and then if we pick the other, and then we just ignore the other one. Does that make sense? So all we had to do to get our thing to walk and recurse is add these lines, right? So this was my function before, it was this, and all I did was add this little bit, and anybody who's done recursion, I mean, it's pretty simple, right? So no big deal. So now we have something that will happily iterate through any document that we want, no problem. I don't know if you guys are interested at all in, like, I think that it's probably pretty obvious to you, like, how this thing works. It's probably obvious to you how this thing works. So the only thing that's of interest here is that both of these, the check URL param and pick one, this is sort of like a quick and dirty way to. Pardon me? You got it. We say at Conductrics we say embiggen, but yeah, yeah, yeah. So is that big enough to make a difference? Okay. So, and I'll stretch this side out a little bit. So conceptually, both of these are just using the same trick, which is that we're going to manipulate our child tasks a little bit, right? So rather than just merrily plowing through and iterating over everything, which is trivial, we're just adding a tiny bit more complexity by, for instance, in the pick one function, we pick one of them at random. So it's easy to count how many children do I have. That's easy, right? And then it's easy to randomly pick one of those, right? So if I've got index positions, I've got 2 children, so that means I can pick from index position 0 or 1. So that lives here. So this will either be 0 or 1. And then you just use the ordinary slice function. There's a million other ways you could write that. I'm just using the slice function to basically leave me with an array of length 1 every single time, but it's random which one it was, right? And then check URL param is almost the same thing. It just sets the child task to null if whatever condition it is didn't pass, right? And so some of you are probably thinking, why is this guy rewriting JavaScript, right? And just remember, though, that the point isn't to create our own programming language. The point is just to give our users who are not technical enough flexibility without the ability to also like strangle themselves, right? So there's no looping. There's no possibility for infinite loops or anything crazy. What's nice about this is that you provide the menu, and then it's like a buffet, right? You provide the things on the buffet, and then your visitors, your users get to create whatever dish they want from the ingredients. So does that make sense? So now, so the second demo, so this is all we've done now is, I forget if I put the CID up here. Yeah, so if we reload this a few times, we should see it going back and forth, right? And that all that's doing is proving that I'm executing the thing, and it's branching and whatever. Yep.
One question, and maybe you addressed this. Missed it, but so is this running as a middleware, or is it a script you're stacking onto an existing page?
Yeah. So in a way, I'm trying to keep it abstract, but yes, what I'm. So let me just show you just to clarify. What I did is down here at the bottom of the page. So this is just an ordinary boilerplate page, and all I did was I embedded this code via just a normal JavaScript tag.
So that allows you to then offer this to any site, because you essentially stack it in onto existing.
Yeah. So then at our company, one of the ways you can use us is it's the classic A/B testing platform thing where you paste a script tag that we provide into your page, and so the end result of all this stuff at Conductrics is that the JSON and all the corresponding JavaScript. What we actually do is we look for all of the handlers that we need that are actually used in the actual JSON. So like how many of these handlers do I actually need? I might not need all of them because the user is maybe not using them all. And then we use Browserify actually to bundle all that stuff together. So the visitor, and then we update the CDN with the result, right? So we hot deploy to our CDN a bundle that contains like this and a bunch of other data, and then all of the handler functions that go along with it. So if you have an empty tree, then you end up with an empty JavaScript document, if that makes any sense. Yeah.
Or the analytics of something like this. Like if you're running an A/B test and you want to know something.
Yeah, so I'm only focusing on the mechanics of this like flow-based programming thing at the moment. But yeah, there's a lot more to building one of these things. Like if you're actually going to use this for A/B testing, one, you could use our product, but if you could use this to roll your own. But yeah, you're going to have to do a few things. You're going to have to, for instance, I'm not addressing in here remembering which variation the person was selected for. So every time we're reloading, which makes for a good demo, every time we reload, we're getting a different selection, possibly. But in the real world, there's an expectation that that's going to stick. You have to deal with ITP and other stuff like that that goes along with it. And then, of course, you have to send some kind of feedback back to some kind of mothership of some kind so that you're counting the number of views and then you're counting the number of conversion events. So there's a whole ton of other stuff that has to happen in order to like actually turn this into an implemented A/B test. But you can use this as the foundation for the logic, if that makes any sense. Does that make sense? And I want to emphasize that this doesn't have to just be about testing. Like you could use this, like what I find exciting about this is that if you squint, like forget the content, if you just squint at it just right, it kind of looks like a configuration file. Or if you squint at it another way, it looks like a program. And if you squint at it a third way, it kind of looks like content, right? It kind of looks like a document. And it's really all three. And I find that just kind of interesting. So you're giving your users the ability to run a JavaScript program of their own design, but without writing any JavaScript. I have one third version of this to show you. Am I doing all right on time? Do I have?
Yeah.
Okay. So here's the third version of it to show you. And all I'm doing here is I wanted to add asynchronousness because in reality, so the prior versions, they all operated synchronously, and that might be totally fine for your use cases. For us, we needed to also handle asynchronous execution, right? Some of the steps in here are going to be asynchronous in nature, looking something up, saving something, or whatever. So I wanted to show how you would make that work. So just to simulate something asynchronous, I created a new node type called wait, and where it takes an argument called ms, just for the number of milliseconds. So this just stands in conceptually for loading something over the wire or any other asynchronous operation. So I added wait up here, and the wait function, unlike the others, returns a promise, and that promise gets resolved after the specified number of milliseconds, right? And then I had to change my this is like conceptually the same thing that we had before, but we're using array.reduce just to deal with all the promises, right? So you end up with, instead of ending up with, essentially you're treating each one of these things as something that can at least potentially return a promise rather than just executing. And so this is boilerplate code that you can find online easily. That's just, when you have a set of promises, how do you execute them serially? You guys might be familiar with promise.all, which allows you to execute a list of promises in parallel, but that didn't meet my needs here. I wanted them to execute one at a time. And so for that, you can just adapt some boilerplate code, something like this. Right, so this is just the asynchronous version. And this is really not substantially different. It's just that, again, so I got selected for A, I got selected for A, and then I got selected for B, and I just did the different things asynchronously. So you can use your imagination. This of course makes no actual sense as a use case, but you can think about different ways in which, what I like about this is that you can mix and match synchronous and asynchronous operations. The user, in other words, the person designing this flow visually, doesn't care about that stuff. They know it, they understand it conceptually, but they don't care about the details of what's synchronous and what's asynchronous. It just all kind of magically works. And we didn't have to write hardly any code to make that happen.
Very fast. So if I have an application, I need to wait 500 milliseconds to have the first paragraph, which have all your configuration, and then render something different and wait for another period. So if you have a timeline, explain how this configuration gonna handle that timeline.
Yeah. So in a more complicated case like that, what you would probably do is you would probably add some additional parameters to this, which would be you would probably, this is what we use, what we do for cases like this, we use the mutation observer API, if you're familiar with that. So what I should have put in an example like that, but kind of conceptually, instead of waiting for a number of milliseconds, you can wait for a selector to appear, like an element that matches a selector to appear on the page.
But what is a chained action, like chained, timeline action need to happen, action happen, how this configuration gonna be changed?
I'm not sure I'm following. Am I?
Like you were asking for like a dependency of
Like
actions.
a chained action.
A chained action.
Chained action.
So like you need something to happen after the wait, and then something happens
after the
explicitly
wait.
after that.
And then something happen after another wait.
Yeah. Well, this will support it because you can keep nesting. So if you, again, I should have arranged this slightly differently. It would probably make more sense. So you can always have, within any of these things, you can have a tasks array. That's like a magic name, tasks, just because it's in our code over here. And so under this thing, you could have a tasks array within this node, and its children won't get executed until this promise fulfills. And so you can chain like that, and you could keep branching. It's a good question. I should have illustrated it better in the example, but does that make sense?
Yeah.
So like these are like kind of trivial examples that are waiting for a number of milliseconds, but yeah, if you wanted to chain, all you would have to do is items, and this is not legit, but I could just like take this and like stick it here conceptually, and then you could nest and nest and nest, and the thing will eventually walk through everything, assuming that the conditions ever actually do materialize. Does that make sense?
Where does the flow JavaScript code actually get looped in during the workflow? Like, is that something that you guys write, or is it something that that we would write to implement the A/B test, or?
So if you're using our product, we do all this for you. You don't have to be worried about this stuff.
So if we wanted like a custom handler to add to your list, we'd have to call you.
I'm
serious.
The very next slide.
The very next slide. Yes, thank you for the intro. But yeah, I think that one of the really nice things about this pattern is that you can also use it to support. So I kind of went through different versions. JavaScript is great, blah, blah, blah. And one of the nice things about it, about this pattern, I think, is that you can also use it to support extensive, you can also use it to provide extensibility features for your product. So again, for us, like ours is a specific product that's about testing, but if you want to, you could adapt the code that we've already looked at to support some kind of custom handlers, so that you can support, so that the user could add their own node types to that JSON document that we're not shipping. Does that make sense? So let's take a look at what that looks like. So, and I'm sure there's a better way to do this, but so here's the last of the 4 versions of this. So what I've done is I've added one more node type called blink, and blink is, you'll notice, is not something that I'm providing in our implementation file. I'm going to let the user create that on their own in their own page. Yeah, no worries. So I took this as an opportunity, because this is the last one. I thought this would also be a good time to do a little bit of refactoring to make this like a little bit more exciting and a little bit easier to use. So I created a new class called Flower or Flower. And so the idea is this is like a new class that you can instantiate, and this is basically your task runner conceptually. And so you call the constructor with your handlers, and that will our constructor. So let's look at how this actually looks down here. So here I am creating a new instance of Flower. So I call it, and I provide to its constructor, I provide the handlers that I want to provide out of the box, right? So without extending. So here I am providing just my default ones that I'm going to support for everybody. So these are the same things that we saw earlier, right? So this is going to empower most of these node types. But notice that blink isn't in here. And so I do some stuff in here, but basically I'm just storing the handlers in a map. I register some default handlers that are always going to be provided. And then basically I take this object that's been passed in, the one with all the different the custom functionality, and I call add handlers. Add handlers just iterates over that object that was passed in, registering each one. That all the registration process is adding it to the map conceptually, right? So that we can find that function later when the thing is actually executing. This is like a go-to pattern for me. I use it all the time. I loosely call it the registry pattern, but I'm sure the Gang of 4 would call it something else. So this is just totally awesome, I think, to almost always use a registry whenever you're not sure like what your app is going to look like in the future. And then the rest of this is almost exactly the same as it was before. Just notice that instead of like it being really ad hoc-y before, like I looked up the handler just like that, and now I'm just a little bit more formal so that there's like a proper get handler function. And that would enable me in the future, and this is something we do at Conductrics, you might have versions. So you might actually have different versions of each one of these things, and you could use the name plus the version to actually look up the appropriate code. So that you could allow people to go forward and backwards in time and that kind of thing. But whatever. The point is, now you have this add handler, and you could use that to register your own function. And so in this version of the code, hopefully I found the right place. So here I am including that Flower instance in my page. And I just put it out in the global scope. If you're using React or whatever, you would do this differently. But so Flower is defined on that other page. And now I can just call add handler, blink, right? So I'm creating my own custom function. And now so now people can ship their own JavaScript code that gets executed along with all the other stuff, right? And so this is trivial code, I think, for most of you. Oh, this is actually a mistake. This should be this.ms, but you get the idea. So the demo for that is like super painful because it's horrible. Right, and so if I get selected for A, I'm blinking these things up here. And if I get selected for B, right, I go through that same sequence and then I blink these things down here. Yeah, right? But, you know, the point is, right, you're actually doing something fairly powerful here. For our customers, what this means is that we can ship all the ordinary A/B test stuff that you would expect. But if they need to integrate a custom library or something like that, where it's like very common that we're going to A/B test whether or not showing a survey decreases our conversions, that kind of thing, very, very simple and trivial for people to be able to incorporate, and like using that drag and drop editor thing to be able to incorporate custom functionality. And it gives you a good separation of concerns as well, I think. So continue. I skipped over just a couple of points, basically done. But just again, you know, JavaScript is so awesome for this kind of thing. All that code is super lightweight. It was really powerful actually and does a lot, but there's hardly anything, and we didn't introduce any dependencies on anything. And all of that code is polyfillable, so you could run it on pretty old browsers if you needed to. Again, we just want to not get carried away with this. You don't have to create a full programming environment. Don't ship an IDE for this. Like, use it for, at least in my opinion, and in my experience, use it for the use case that I kind of outlined at the beginning, which is giving your power users, like we have a whole WYSIWYG thing, right, where people can just drag and drop and like edit pages visually. But for the cases where they need to get out of that box and go beyond what you could do easily in a WYSIWYG type of setup, we give them that visual editor that we showed, the diagram-like editor at the beginning. And either way, they end up with the same thing, right? So if they use the WYSIWYG tools, they end up with a JSON tree. And if they use the diagram thing, they end up with the JSON tree. Then that gets stored and gets shipped out and all that kind of stuff. So it's just kind of a nice modular way to do stuff. This runs anywhere you can run JS. Obviously, my handlers were browser specific, the stuff like Blink and whatever. But, you know, like those examples like the if then then that and the other stuff that we were looking at the beginning, those screenshots, those were all sort of more like orchestration or automation type use cases that those things are supporting. And so this stuff, right, rather than being sort of browsery, could easily be send an email, could be, you know, save some record to a database, get some information out of a database, all that kind of stuff. So it can easily be back-end type information, and that's like, so when people are using us on servers, that's more the stuff that they're doing. Editing, like I said, I didn't have time to go through that editor, that diagram-like editor. It is pretty neat, but it is mostly stolen straight from an example, a D3 example. So the visualization is done D3, which is an awesome, awesome library. You just got to check it out if you've never checked it out. Like if you're bored with like learning about the latest framework or whatever, and you want to see something like truly innovative, look at D3. So I started with this one example, and I just adapted it to our needs. But it was really pretty straightforward. And then, like I said, in Conductrics, our product, and this is just interesting that, like, you know, people could start off making their changes WYSIWYG style, or they can record page edits. Like they can open up their browser dev tools and hit record conceptually, and then we'll record all the changes that you make using your browser dev tools. But either way, you end up with just that JSON tree. And so, you know, you could do things visually, WYSIWYG style, to get most of the way there, and then finish up by editing the tree in the diagram mode. We didn't get to any kind of value passing, right? So I didn't, and we don't actually do this in our implementation. You might have a situation, and like these show more complex relationships between nodes where they might actually be explicitly passing bits of information to one another. Those are usually called inlets and outlets. So you're connecting an inlet to an outlet or vice versa. And those just really are conceptually named parameters being sent back and forth. It'd be pretty easy to add something like that. But if you're going to go that far, and if you need something that complex, we needed something super lightweight because we have to ship this out to browsers and stuff. But if you wanted something more complex with all of those bells and whistles, then it might just make sense to use a framework. One that's out there is the no-flow framework, which is very fully featured, which has a whole fancy editor, and it's really fancy. So I would encourage you to check that out if you have any interest in this. Just some inspiration and so on about flow-based programming. This guy, Paul Morrison, J. Paul Morrison, he was the kind of the inventor of it. He invented it in the 60s. And so I'd invite you to take a look at this site. Just Google flow-based programming. This will be like one of the first things that comes up. It's pretty interesting, far more complex than the stuff that I showed you. This is his book, pretty cool. Oh, that's a repeat. Oh, yeah, and then just, again, the No-Flow project. That's an open source project. I think it was funded via, GoFundMe or something like that. So it's semi-supported. Pretty cool. Hope that was helpful. I'm happy to answer any other questions, but I'm Nate from Conductrics. Yeah, most likely. So we are this close to signing. We have a bunch of pretty household names as clients, none of which I'm authorized to say. But there's another one that if we sign them, which should be imminent, then we're going to be looking to hire. It's just only one person, but we are looking to hire someone that has familiarity with sort of analytics or testing and JavaScript, especially in the front end.
Cool. Anyone else have any questions for Nate?
I thought the use of this was really clever, and that wouldn't have occurred to me as a solution, so I wanted to say that was really impressive. But also, why is Lana Del Rey your mascot?
Because she's awesome. Yeah, but like every one of our, not that this matters, but like each one of our releases is named after a Lana Del Rey song, and yeah, so like the release notes always link to one of her videos, and I don't know, she's all over the code comments, and what can I say? One of the problems is that most of her lyrics are not safe for work, but that's a separate.
It looks really cool, though, I have to say. Like the whole flow design, drag and drop.
Yeah.
Cool. I like it.
Yeah, this is actually the second time I did this. The first time was my then colleague Jesse, who isn't here today, but who works with me now at Conductrics, and we built it for Under Armour, and that was the basis of their back end for a long time. It is no longer, but it was very, very similar conceptually, and it's how I learned a bunch of things to avoid. So this is a simpler implementation.
Are you publishing your slides anyway?
I could, yeah.
You just send them to me. I can blast them out.
Yeah. So I'll send them to Shimon. Thanks, everybody.
Thanks, Nate.